Alright, let's see how you guys did. Okay. Kiddos, you multiplied out, right? You didn't do any illegal foiling because you know not to kill puppies because you guys are old enough to know that that's wrong. So therefore, you got this first, right?
Yeah.
No killing of puppies? Good. Then you went ahead and multiplied a little bit more. You got 250 x to the fourth.
Yeah.
Plus 100 x squared.
Wait. X to the fifth.
Ooh, nice, because I multiplied by x as well. Good catch, good catch, good catch. X to the fifth plus 100 x cubed plus 10x. Ugh, what do we still have to do? We were just rewriting. Ugh, we got to integrate. AKA find the antiderivative. True. And power rule says add a power and divide by it. 250 divided by 6 is nothing even. But we can simplify. Is it 125 over 3?
Yeah.
Nice. Thanks, mental mathers. Plus, we have x to the fourth. 100 divided by 4 is 25. That one's nice. Plus, x squared. 10 divided by 2 is 5. Plus c. Don't forget plus c. Don't forget plus c. Anyway. Dun, 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 dun. Now, what if I wanted this factored? How do we factor it? Maybe there's another way to solve it, and we'll see what the other way to solve it is, where we don't have to factor something gross. But actually, is it really all that gross?
Yeah.
If there are x squareds in everybody?
Not in the C.
Well, we just leave the c off to the side. But if we pull out the x squared, do we still have an x to the fourth that we still don't want to factor?
Yeah.
Ah. So let's go ahead and see if there's maybe an easier way, because who liked all that? Probably not many. Goal. We have a goal today. And actually we have a goal for this chapter 4B part, where we might see some FRQs. It's about time. Some of you have been a bit nervous, and I've been a bit nervous for you, but we can't keep putting it off forever. Goal. New techniques for integrating complex fractions. Functions. Does that mean imaginary? No, what I just mean is more complicated. So if you're all mathematical and you say, well, complex doesn't mean complicated. Okay, fine. Then don't put complex. Put complicated instead. Or you say harder. There. We'll dumb down the vocab.
More hard.
Isn't that your guys' no, we're not going that far. Isn't that your guys' generation?
Yeah.
Mess up all your grammar and just kind of cut down words and
Yes.
basically barely communicate.
Yep. Well, I believe we're enhancing our communication with simpler and faster writing.
Go shorthand.
Whoa, 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 whoa! Why are there U's on the screen? Chain rule. To help us with new techniques for integrating harder functions, we are going to first have to think of chain rule. Because chain rule, whenever we were deriving, we would have to take the derivative of the outside, keeping the inside the same, times derivative of the inside. Remember the Matryoshka dolls? Onions have layers, and so do
Ogres.
ogres have layers.
Yeah. That's the moral of the
That is
story.
the
Moral of Shrek.
Oh my goodness, this is so sad.
Someone do that.
So do compositions and functions. The end. All right, fine. So f of u. Come back. F prime of u times u prime, which means now we have a new integration rule. The integral of. Wait, why does it say f prime? Whoa, why does it say f prime? If we're going backwards from a derivative, because capital F. Because capital F is the antiderivative of f. Remember, over here on the left, I've kind of given you a reminder. Capital F prime is little f, so when we put little f, we are putting a derivative just of the antiderivative. Yeah.
yesterday.
Oh, that's awesome. Okay. So with this new integration rule,
Figuring out this
I'm coming back. Hold on, Ange. With this new integration rule, we are going to see multiple pieces. We're going to see the first part of chain rule and the second part of chain rule, and we're going to go back to one single composition of functions antiderivative. That's where it's going to get a little bit harder. Or like down here, we're going to see two different pieces. We're going to need to go back to a single composite antiderivative. Angela, go ahead. Oh, Ella, that was you?
Yeah. Can you put this on the board?
To be honest, we're not going to memorize this. So it's more of a, oh, so chain rule we can go backwards from. Okay, let's see how it works. Does that make sense?
Yeah.
So hang in there. Hang in there. All right, let's go see an example. Wait a minute, what example? The one we started with. What? No. The only way to solve the one we started with was to FOIL and to multiply and then to rewrite and then to use the power rule. And then to say, oh, stink, we don't want to factor him. No, there is another way. Can you guys look at the chain rule backwards, the theorem up above, the chain rule backwards, and try to identify for me how this example fits into that formula?
Oh, so we have to
10x is the derivative of 5x squared.
10x.
So 10x could be the
And then we plug it into.
u prime.
No, hold on, I want to do it myself.
So this could be the u prime. We have our d of x just chilling. Who would this guy be? No.
F of u.
F of g of x, how do we write him though? If we put him in terms of u, because we found the u prime, who is u? U is 5x squared plus 1, because didn't we say the derivative of 5x squared plus 1 is 10x, right? So we can put u, but not just u is there.
There's a squared on the out of it.
There's a square, right? So we could say f of u is u squared, right? F of u is u squared. Okay, so hold on. How would we go back? We have the integral. And to rewrite this a little bit nicer, guys, I'm going to go ahead and actually write it how it should be written, which is u prime dx is the same thing as, yeah.
Off in the margin there, would u prime be 10x or just 10?
Oh, sorry, did I not put that? I didn't.
Oh.
So that means du dx is equal to 10x. So I can say du is equal to 10x dx. Now see what we can do now. Now we can change this to the integral of u squared du. D is differential, remember? dy dx, du dx, dv dt. D is just a differential. So I can change this little statement right here. I can change u prime equals 10x to be du. Remember differentials, guys? Du multiply dx on the other side. So I went ahead and was able to do one more substitution and say that this guy was du. Why is that good? Haven't we learned how to integrate no matter what letter, as long as whatever is here is also over here? Oh. Kiddos, ignore the rest of the problem. Just zoom in right now on this part and say, hey, if I had to solve for his antiderivative, what would I do?
1.
Oh, wait, u to the n
One
plus
to
1
the
over.
power.
U to the n plus 1, which specifically is u cubed over 3, but I can't forget my plus c. Right? Oh, so we're done. No. Why? The problem started with x's. What should it end with? X's. So how we go ahead and solve?
Plug in u.
Plug in u, and who was u?
5x squared.
5x squared plus 1. Dun, 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 dun. Wait, who's that guy?
This looks so much cleaner.
He's the same as that guy, but he's nice and faster. And Ryan's like, hey, if we want to check and make sure that these are the same guy, we can always do the whole Pascal's triangle thingamabobber to cube it, because cubes are what, 1, 3, 3, 1? So we can do 1/3 times 1 times 5x squared cubed plus 3 times 5x squared squared times 1 plus 3 times 5x squared to the first power times 1 squared plus, plus 1 5x squared to the 0, oh, he's gone, times 1 cubed.
Can't we just trust you?
That's no fun. So then we end up with 5 cubed is 125, so I have 1/3 of 125 x to the 6 plus 1/3 and 3 cancels out, so I have 25 x to the 4 plus the 1/3 when I distribute cancels out with a 3, and I have 5x squared
Yeah.
plus, and I have 1 plus c.
That's not right.
Wait, that's not right. Yes, it is. Because constants can combine to be a new
Oh.
constant. Dun, 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 dun. Question, but who do you like better? Top guy,
Definitely
bottom guy, or
bottom.
side guy?
Bottom.
Side's your
You
favorite?
cannot vote.
Let's get rid of him. Bottom guy is so much cleaner, so much nicer, so much better, and hey, he implements what we just talked about as far as chain rule backwards. Chain rule backwards. Let's see if we can do another one. Oh, never mind. Let's see if we can write steps. Use up. Use up. Which I could make a forever card, but no. Why? It's more of a process that we are just going to get used to. The same way we had to for chain rule. Although I guess we memorized chain rule. So if you guys noticed, we started with, hey, there's a U prime. But the only way you can figure out there's a U prime is if you can figure out who U is. And we want to let U, as much as is possible, be the innermost function, which we started practicing in pre-cal last year when I would give you composition of functions and ask you to decompose it. And figure out who is the innermost and then the outer and then maybe even another outer. We were getting ready for the chain rule. And integration by U sub. But choose wisely. Guys, wisdom, is that something that's born right away or something you have to work at getting? Yeah. Of course, in Proverbs it says the fear of the Lord is the beginning of wisdom. So maybe it's not totally dependent on our work. However, it takes time,
Perseverance.
takes perseverance. Anything else? Humility to admit the weaknesses to be able to grow. Semicolon. Yes. Find du, semicolon, then solve for dx. I guess maybe the semicolon isn't the proper notation. What is it, a comma? Oh well. Is then a proper conjunction?
Yeah.
It's not, is it? And that or no more? Maybe a semicolon. I could just take out the then and just say solve. Then a semicolon is definitely right. Find u, solve for dx. How? U prime. And u prime equals du dx, and so if it helps you to connect the dots from the last example, I can solve for du by making it u prime times dx. So that's a quick reminder of differentials. If u prime is du dx, which it is, then I can say that du is equal to u prime dx. We multiply dx on the other side. Then we want to rewrite the integral in terms of u and du, because if we can get it totally rewritten in terms of u with a du at the end, then we can just go find an antiderivative like normal using all the rules that we talked about before. But instead of things like the integral of sine of x dx is cosine of x, negative. Cosine of x plus c, we can say the integral of sine of u du is negative cosine of u plus c. And then replace u with its function in terms of x, if you need that little extra reminder. In terms of the original variable, remember somewhere, bless you, bless you, bless you. Somewhere you're going to have u equals the inner function. Somewhere you're going to have u equaling the inner function. So you're going to replace u with who he actually is, and don't forget the plus c. If it's an indefinite interval. Now kiddos, here's the dealio. If I say homework's not due till Tuesday, and this is basically the main point of section 4.5,
We can do it.
we need some practice, yeah? But didn't we practice with chain rule? Didn't it take a while to figure out who is u and then take the derivative and don't forget the u prime? Hey, wait a minute. Do you guys see the bunny rule? The bunny rule. Every time you do this, a bunny dies. If you guys can't see it, hold on. Just wait. Wait for it. Oh, my finger's on it.
That's neat.
Oh, is it going to be focused enough?
Now we play the waiting game.
Hey, it's like that one meme where it's like,
Let's see if I can get it.
Those are probably one of my favorite movies.
hey,
It
dude,
literally
now
just
I'm on the
freezes.
screen and in front of you.
Oh my goodness.
Inception.
I did the
Matception.
I really stressed it out. Poor little guy, what's going on? I turned you off. And he's just not happy.
Still there.
Let's try again. Take two. Aha! There's the bunny rule. Let's see if we can zoom in. I doubt it, but we'll try.
Look at those
Kind of.
pictures.
The top of the bunny rule. He says the derivative of sine of 6x is cosine of 6x, and the integral cosine of 6x dx is sine of 6x plus c. Now hold on, don't worry, I'm going to write it down. Let me go back to my notes. Okay. Will that have any lunch? Maybe. Oh, this is my mom's iPad. Yeah, she has nothing. I do. She doesn't. Okay. Page below. So wait. Bunny rule. Here are the two rules. Question: why does this kill a poor little bunny? Don't ask why it actually kills a bunny, but why is it illegal? And so we try to say it kills a bunny so that you don't do it. What is wrong with him?
No, you
There's no u prime. So to save a bunny, we say times 6. But we don't write it like that, 'cause that's disgusting, so we write it like this. Okay, the bunny is saved, right? What was the other way a bunny dies? If we have the integral of cosine of 6x dx, sine of 6x, plus c. Look, they even got the plus c. He's alive. Sine of 6x plus c. Question. Why is this illegal?
No.
Every integral you can check by doing what?
Right.
Deriving. What is the derivative of this guy?
Not that.
Cosine of 6x
Times.
times 6. Nope. Derivative of c is 0, right?
Yeah.
Well, wait a minute. That guy's not that guy. Oh. Well, how do we... If we have cosine of 6x times 6, Katrina just helped us out. She said, oh, if only there was a 1/6 there as well. Because if there was a 1/6, what would happen to the u prime? But if there's a 1/6 here, question, what should have been here? This is the correct answer. But how do you get there? How do you figure that out without just making jumps? We say, you know what? There's a u. Oh. And if there's a u, that means there's a u prime, right? U prime, I'm going to put a little colon because we want to actually get du. What's the derivative of 6x, guys? 6, and then we're going to put a dx. Because that allows us to go ahead and in the integral say cosine of u times, oh wait a minute. How do I plug in? I don't have a 6 dx. But what do we have to plug in for? So we're going to go ahead and divide both sides by 6 and say, oh, now plug in 1/6 du, which is going to equal 1/6 can come out. We have the integral cosine of u du. Isn't that sine of u plus c? And then we say, oh, who is u? We go back and say, there he is, 6x plus c. Now guys, that's u sub. We got to do some practice to help us get there. Yeah? So bunnies can die if you don't do u primes, and bunnies can die if you don't do u sub. So we have our steps. Let's go do some examples. The easiest type of u sub is when u prime fits exactly in. The easiest type of u sub is when u prime fits perfectly, fits exactly. And what do I mean by that? Well, let's see. Let's see. Who is you? Now, who are you? Who is you? X squared minus 10? Ryan, how'd you make that deduction?
Because it's the inner function.
It's the innermost. He's stuck inside a square root. He's the innermost. So if u is equal to x squared minus 10, well, that's going to help us somewhat, but we still have that dx. Oh, derivative. Okay, let's go find u prime. U prime, du is equal to what? What's the derivative of x squared minus 10? 2x dx. So we're thinking u prime, but remember we're writing it du equals u prime times dx. So if you want to make the connections real quick, technically u prime is equal to 2x, which means du dx is equal to 2x, which we can change to be du equals 2x dx. But do we want to write this in 3 steps every time?
Yes.
So what we're going to start doing is what you just saw me do. In order to do u prime, we have to think u prime, but we're just going to go ahead and say, hey, take the derivative of everybody. Which means, take the derivative of u would be 1 du. Take the derivative of x squared minus 10 would be 2x dx. Hopefully we'll get to the point where we can just jump straight there. But all the work for it is over here. Kiddos, can I start substituting in my integral? I think so. So we can rewrite this integral to be the integral of u is right here, right guys? What's going on to u? He's square rooted. And what am I going to do? So that's a check on this guy. What am I going to do with 2x dx? Plug in du. So I can just do square root of u, du. I can rewrite that, because who wants to take the derivative of that guy when you take the, antiderivative? When you can take the antiderivative of u to the 1/2. How are we going to do that?
N plus 1.
We're going to do our power rule. So then 1/2 plus 1 is 1/2 plus 2/2, right? 3/2. Times the reciprocal 2/3 plus c equals. We don't stop with the u. What do? Plug in who he is. Who is he? X squared minus 10. So we're going to go ahead and have 2/3 x squared minus 10 to the 3/2 plus c. Dun, 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 dun. And how can you check if you're right? The same way we always did. You would bring down the 3 halves, cross, cross. You would have x squared minus 10 to the 1 half, square root, times u prime 2x. Aha, it matches. So we are taking an integrand, a function and an integral, that was gotten, you can think of, that was gotten from an antiderivative who needed u prime, who needed chain rule. Hence why we have to do the u sub to break it down. Now, you guys are already seeing number 2 down below. Oh no. Trig has come. As you guys are writing the second example, some of you can start going right away. You have to choose though, who is you? And I kind of see 2 choices. As you're thinking about it, is anyone still stuck on number 1? Is anyone still stuck on number 1? Because we had to see that what else was up there, the 2x, did have a meaning or did have a way of representing it in terms of u. But it's not u itself, it's the u prime. Because whenever you have chain rule, Angela, going back to the theorem real quick, if we're trying to take the integral of a chain rule, we can't just have f of u, we have to have a u prime as well, or else it's illegal for us to go back. Does that make sense? So every time we're going to do u sub, we can choose a u, but the problem is, if I stopped there, no one write this down in case you're tracking with us. If I only did this step right here, I would only be able to rewrite this as 2x root u dx. I can't do anything with that because I'm integrating with respect to x and I have a random u. That means nothing to me. Does that make sense? But if I can get it totally in terms of u with the du and a function of u, now I can try to integrate using my rules. Is that cool? Yeah. Because it was d. Now I'm just going to play, I don't know if devil's advocate is the right word for it, but it's the idea. I'm going to play the calculus student that kind of gets u sub and chooses the wrong one because it's very possible that you would. What if we were to say u is equal to, don't write it down because I just said I'm choosing the wrong one. What if I was to say u was secant? That could be possible, right? Because technically we could rewrite this guy to be tangent of x. If I can spell tangent, struggle. Tangent of x cubed. So tangent is inside, but isn't secant inside also? Now some of you are like, yeah, but his power is smaller. To be honest, it doesn't really matter. There's another reason why you should not choose u to be secant. But hold on, let's just say I did choose u to be secant, okay? Like we were just talking about, Angela and I. You can't just stop with u. You have to think of the u prime. This is chain rule backwards. So what is the derivative of secant? How can I plug in? Well, we could go ahead and say, well, I see a dx. Let's start there. Let's solve for dx. Let's go ahead and divide by secant tangent. Divide by secant tangent. Sorry, that was next. Then I could plug in and see what's left before I even do the u sub. Let's plug in the du instead. So I have tangent cubed, secant squared. I'm going to plug in for dx. So I'm going to get du over secant x tangent x. Can I reduce anything? Yeah. I can cross off a secant with one of the secants and a tangent with one of the tangents, right? What do I have left? I have the integral of tangent squared secant du. Uh-oh. Well, I still need more u's in there. Oh, I have this. U equals secant. Well, can't I go ahead and plug that in? And I'll have the integral of tangent squared x times secant, which is u times du. But now I have a tangent. Well, some of you might be like, but wait, tangent squared, that's a pre-cal property. Tangent squared is the same thing as secant squared minus 1. And maybe I could actually make this work. To be honest, you could. But do you see all that work? Maybe I should have chosen secant to begin with. Did anybody try choosing somebody else besides secant? Who's the other guy to choose? Tangent. Let's see if tangent might work any better. Now, guys, you're still technically choosing an inside. And for one reason or another, maybe you don't realize, but if you choose tangent, life gets a whole lot better because here's tangent. Who would u prime be? Oh, life just got a lot easier. Because what do you notice about secant squared of x dx? I can just do a straight substitution, right? I can just do a straight substitution. I can say it matches perfectly, so why not just plug it in, and I can get the integral from, who can I make tangent? U. And who can I make secant squared of x dx? U. Oh, that looks nicer. Katrina.
How come some of the problems solve for dx?
Technically, I'm getting you ready for the harder ones where they don't match perfectly. We could, and it's not a bad idea. I think I actually did it a lot more last year. We could, give me a second, see this match, but we could still go one extra step and say, all right, well, let's go ahead and solve for dx. And if we did solve for dx, then we would get dx equals du over secant squared. So when we go to plug in, we would plug in du over secant squared of x. We have secant squared of x. And then we know that tangent is u. So we're going to get to the same place either way. But if we solve for dx, that's especially preparing us for what if they don't perfectly match. Dx will always match. So if you solve for him and plug in, hopefully it'll work out whether it matches perfectly or not. So still we end up either way with u cubed du. That's just a simple power rule. And Angela, we were talking about earlier, this is nice because it's all in terms of u again. So now, how do we integrate something to the third power? Add 1. Divide by plus c. But we're not done yet because what do we need to do? Plug in u. So let's go plug them in. U is equal to tangent, so I can go ahead and make this 1/4. We could make big old parentheses tangent to the 4th, but that's yucky. Why not just do the nice, don't get tricked by the trig notation, tangent to the 4th of x plus. Dun, 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 dun. Dun, dun. How can you double check? Derive it. This little 4 would come down. He would cross out. He would become a 3, and he would be times u prime, which would be secant squared of x, and the plus c would be a 0. I'm just trying to show you my mental math, but yes, we could plug in. Sorry, we could derive and it would match the original integrand from the beginning. So this entire page was, what if u prime fits exactly? What if the du matches exactly all the extra stuff in the integral that I want to get rid of or substitute for? What do you guys think the next page is going to be? What if it doesn't fit exactly? But there are 2 different ways it could not fit exactly. And one of them is, what if u prime is only off by a constant, not a variable? What if u prime is only off by a constant? I want you guys just to see how you would start. Hopefully you can choose a u and then find a du. Some of you might be able to keep going based on what we've done. Some of you might get stuck there, and that's okay. But just see, what would you make your u? And then find du. Good thing with u sub is you're practicing differentiation, which we haven't done a lot of recently. So in integrating, you're practicing deriving. That's good. I'm going to start solving slowly. It takes a little while to figure out what U to choose, guys, so I'm not saying this is easy. We're just trying to get you used to it. Looking at the innermost kind of thing, chain rule, who would be your U? How did choosing U and DU go? You guys agree?
Yeah.
You see why I chose 1 plus 2y squared? He was in the square root, he was in the radical. Alright, focus on that. My U was under my radical. Du, derivative of 1 is 0, derivative of 2y squared is 4y. Plug in! Does 4y dy perfectly match the extra stuff I got? No. So let's use what Katrina was saying earlier. Why do you sometimes solve for who does match? Dy. So let's go ahead and solve for dy and say, all right, fine. Who is dy? Du over 4y. Now let's plug in. So I can plug in, okay, the y doesn't perfectly match anybody, so whatever. The square root, well, he is just kind of still there, but who's under the square root? U. Times dy is going to get substituted for du over 4y. Now, is there any simplifying I can do? We can cross out those y's, right? So the y's reduce. How can I rewrite this to make it easier for me to integrate, guys? Pull out a 4, and then we're going to integrate square root of u du. Wait, that's a very common illegal step. We can pull out, but where's the 4? It's in the denominator. It's not a whole 4, it's a 1/4. Careful, 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 careful. Some of you just don't see the 1 up top. It's understood. The coefficient is 1/4. Pull the 1/4 out. Now we might still want to rewrite, right? But isn't he all nice and set up and ready to go? We have everything on the inside in terms of u. So we can just go for it. Nothing else is holding us back. So hopefully you guys are getting right now. U to the times the coefficient. And the 1/4 is still chilling. Plus c. We can end up reducing the fraction just a little bit. 1/6. 1 plus 2y squared to the 3 halves plus c. Actually, we don't have to worry about the 1/4. Even though Brandon's right, we could think of the 1/4 as being outside of everybody. But when the 1/4 comes in to the 2/3 u to the 3 halves, that's great. And when the 1/4 comes into the c, isn't 1/4 times any constant just going to be any new constant? And we're not doing the whole like c1, c2, c3. We can just call them a new plus c. What if the AP guys didn't have that as a multiple choice answer? Would you just automatically go to none of these?
No.
Or would you make sure that they hadn't written it in some other funny way? Isn't that the same thing? Remember, dividing by 2 is just a root? Or isn't this the same thing? Now, I doubt they would show the bottom one, but still technically. These are all ors. Because 3 halves, what is that power? 1.5. Do you see the 1.5 down below? So all of them mean the exact same thing, just trying to get you ready. But I've seen AP guys, to be honest, guys, Usually, if it's kind of messy, they usually leave it in fractional exponents. Unless it's something that can be simplified. Questions before I move on? When it's off by a constant. Chose u. Found du. Didn't match. That's okay. Solve for dy. That does match. Plug in. See if the problems go away. Coefficient comes out. No big dealio. Solve. Dun, 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 dun. So let's see if you guys really got it. Your turn. Come on. You have to put all your skills together. Part of it can be ignored as a u prime. Part of it hopefully matches an integration rule we know. And part of it is a u. And it's tricky, it's okay. Part of it can be ignored as a u prime. Part of it should match an integration rule that we know, and part of it is the u. Give you a couple more seconds for those of you that are confident and want to try on your own. For the rest of you, we'll talk it through. Wait! It's okay. Should u be tangent? No, because du would be secant squared. Should u be secant? No. Who is u? Some of you might want to try that tonight. Maybe you can start over. Maybe you can just try this one example and see how it goes and be ready tomorrow to learn more. All right, cool kids, I'll see you later. Bye. Homework, I'm hoping to have up by lunchtime.